Hello again. This video is on velocity time graphs and their usefulness and that sort of thing. So velocity time graphs. So if we look at a velocity time graph here, so I've got velocity here, time there. Let's just look at a silly example or something. But if we've got let's say we're traveling along at 2 meters per second, so constant velocity. And then if I stop walking, so this I'm going 2 meters forward, so positive direction. If I stop walking and start traveling back in the opposite direction at 2 meters per second, going in the other direction, so -2, let's have a think about what's going on here. And let's just have a few more things. Let's say that's for 3 seconds, and that's after 1 more second. So I'm walking for 2 meters per second to the right. Let's just say the right is positive. And for 3 seconds, I stop, I turn around and walk in the other direction, -2 for 1 second, up to 4 seconds. If you think about that, what would be, how far have I travelled in that time? So I'm walking for 2 meters per second for 3 seconds. How far do I travel? So let me just write that down. I'm travelling at 2 meters per second for 3 seconds. How far have I travelled in that time? Well, 2 meters per second times 3 seconds, 2 times 3. So that'll be 2 times 3 in this time. In other words, it's the area under here, 2 times 3. So the area under this graph locked in here is the distance travelled in that time. How about in here? I'm travelling at -2 meters per second in here, and I've done it for 1 second, Okay, and so what have I travelled in that time? Well, in that travel I'm still travelling at 2 meters per second, but I've gone in the opposite direction, so I'm going back where I came from in a negative direction. And so in here I've travelled 2, but in a negative direction. Okay, so -2. Here I did +6. Okay, and so what we look at is the area between the graph and the t-axis on a velocity time graph tells us how far we've travelled in that time. So in this time up here, I've travelled +6. So if I just do a little timeline, so not a timeline, in the first 6 seconds, I've travelled 6 in this direction. That's how far I've travelled. And then I turn around and I go back and I travel 2 in the other direction. So I end up at 4 sort of thing. So that's what's going on in this particular graph. And it's actually really useful in a velocity time graph. The area under the graph tells us the distance travelled in that time. And you'll notice if the graph is above the line, then we get a positive distance. If the graph is below the line, we get a negative distance. And so I'll just go to a new screen now and just write a few things. Okay, so if we want the distance travelled, what we want is we don't care about whether it's positive or negative. We just want the total area under the graph. Okay, so just add up the areas, so unsigned. We're not worried about the sign of the area. Positive, negative, don't care. Just add up the total areas. If we want the displacement though, we need to take into account how far in the positive direction we've gone and how far in the negative direction we've gone, so we know where we end up. Okay, so what we want is actually the signed area under graph. Okay, so if something is positive, so something like this up to there, that's the positive area there, and that's a negative area there under the axis. If we want to know the displacement, we need to find out this area minus this area here to find our final displacement. And so that's really important to know on a velocity time graph. And sometimes it'll be the area of something nice, like a rectangle or triangle, but quite often we'll have the area under some function, a curved function. And when we do that, we need to use integrals, because the area is equal to the integral, let's say from 0 to a, and this is function f of x. the area will be from 0 to a f of x dx. We need to use integrals sometimes to find those areas. Okay, let's do an example. Okay, so an example, let's have a look at this one. So here is a velocity function. Let's have a look at what's happening here. So it starts at negative 10 meters per second, so it's going in this direction. Okay, negative 10 in a negative direction. But what's happening is it's slowing down. It's getting closer and closer to 0. So it's still going in a negative direction, but it's getting slower and slower and slower. And so it goes slower, and then at 3 seconds it stops and it starts going in the other direction. So it starts getting faster and faster and faster in this direction. And then at 5 seconds, at 5 seconds, it travels at a constant velocity for this entire time here. For how many seconds is that? For 5 seconds. It's traveling at 6 meters per second for this time here. So constant velocity. And then here it starts to slow down, and it comes to a stop. Its velocity is equal to 0 at 11 seconds. Okay, so that's what's going on. Got to get used to learning how to read these things. That's what we've got here. So in these examples, let's have a look at this. Okay, find the distance travelled. Now, in the first 3 seconds, this area here will tell us how much it travels in the first 3 seconds. Okay, and then from seconds 3 to 11, this area will tell us how far it travels in that time. And so let's just calculate our areas of these, and I'll write them in nice red so that we can sort of see what's going on. So here, what's the area of this triangle? We've got 10 here, 3 there, so 10 times 3 is 30, divided by 2, so that area there is 15. 15 under there. Okay, right. How about this here? We've got a trapezium, and so the area of a trapezium is its base and its height, the average of that. So that's a distance of 5 there. It's 8 there. So I'll just do a quick calculation. 5 plus 8 divided by 2 times by its height. Its height is 6 times by 6, and so that's equal to, that will cancel with that, and that's 3. 5 plus 8, 13 times 3, that's 39 in there. Okay, so I've put an area of 39. And so let's have a look at this. I've got an area of 15 and an area of 39. Just so I can see it nice and clearly. Now what this is saying, that in those first seconds it travels 15, but it's travelling, remember, in a negative direction. So it's actually travelling negative 15. That's its displacement. It's going that away, so it's going at negative 15. But then it starts going positive, and in that time it's going positive 39. It has it ends up travelling another 39 in a positive direction. So the total distance travelled, remember, total distance travelled, it's unsigned. In other words, we don't care about the sign, so we just look at the total areas. So it travels 15 meters in the first 3 seconds, and then it travels 39 in the last 8 seconds, and so for a total of 54 meters. So that's the total distance it travelled. Part B, what's its displacement? Well, its displacement will be its signed area. Okay, so what we want is its signed area, so that's equal to negative 15 plus 39. Okay, and that's equal to 24, pardon me, 24 meters. Okay, and that's obvious because it's gone negative 15, so it's gone 15 in that direction, and then it's gone 39 in that direction, and so it ends up at 24. And so that's a nice little simple one, and I think I might just leave it at that. It doesn't get much harder than that. Well, it does, but you just need to figure out curves and that sort of thing. So just remember that the area under the curve tells you its displacement. If you're trying to find distance, don't worry about whether it's positive or negative, just add up all the areas. If you're trying to find displacement, worry about the positives and the negatives and see what happens with those. That's basically all there is to velocity time graphs. You get more difficult questions, but I'll leave those to class to explain.